name is associated. And now I slip into saying Bragg because that now implicitly means WL Bragg, and I'll refer to WH specifically when I need to. So this is WL Bragg's law within months of Lowy having invented X-ray diffraction from crystals. It explains Lowy's photographs, which Lowy himself failed to do. And these are the words of W.L. Bragg himself from his book of reminiscences in 1975, The Development of X-ray Analysis. And the idea was that, similar to reflection from a mirror, you could have planes of atoms in a crystal, and the X-rays would come in, and at a particular angle you could get constructive interference and a reflection from the crystal planes. And if the angle was wrong with respect to a particular wavelength of the X-rays, you would lose that reflection. And this is Bragg's law. Very, very famous in the field. Now, why is it so stunning that that should happen? So here we have a microwave equivalent, and I'm going to show you the constructive interference. So this is now the transmitter, here's the receiver, and I take my hand away, the receiver picks up a part of the signal. Now if I put my crystal in place and arrange the angles by rotation here, and I'm going to alter the angle of the receiver, I'm going to come in and out of the constructive interference condition, and when I get a signal through the loudspeaker, I'm going to have my reflection. So this is a microwave analog of the X-ray experiment. So if I adjust the angle here of the crystal and then of the detector, I can have a reflection. That is Bragg's law. And with that came the understanding of the interpretation of the X-ray diffraction photograph. Fantastic.